Now we are going to discuss four variable K map. In case of four variable K map, the Boolean function has total four variables. So in this way, the number of squares of the K map will be 2 raised power 4, which is equal to 16. Now in the figure, we have drawn K map having 16 squares. These squares are labeled by 0, 0, 0, 1, 1, 1, 1, 0 along the horizontal direction, and along the vertical direction we have again 0, 0, 0, 1, 1, 1, 1, 0. In the horizontal direction we take the variable CD, and along the vertical direction we have taken the variables AB. Now the different minterms are in the different squares. For example, the first square has minterm M0, then M1, then M3, then M2, and in the second row the first square is M4, then M5, M7, M6. And in this way, all the minterms are represented in the different squares. Now, if we take M8, corresponding code in the binary will be 1000, which represent decimal number 8, and that is why this square has M8 minterm. In this example, we have a Boolean function f a b c d. Now this function depends upon 44 variables a, b, c and d, and it is equal to sigma in the bracket 0, 1, 2, 4, 5, 6, 8, 9, 10, 12, 13. 0 mean we have minterm M0. Similarly, 1 mean we have minterm M1, similarly M2, M4, M5, M6, M8, M9, M10, M12, M13. And the sigma indicates that we will take sum of all these minterms. So, in the function we have all these minterms. Now we draw K map of 16 squares because we have 4 variables and the total number of squares will be 2 raised power 4. In the figure we have drawn K map having 16 squares. Now in the function, in the given function, if a minterm is M0, which is given, so in the particular square we write 1. Similarly, M2 minterm is given and we will write 1 in the corresponding square. In this way, all the minterms which are given in the Boolean function, and for each minterm we will write 1 in the corresponding square. Now we are looking that the first 8 squares in the K map are the adjacent squares, and these adjacent squares are marked in the blue color. So all these 8 squares are combined, and therefore we will write its term. So by writing term, we will see that along the vertical direction, if we move from first square to the second square, then the variable b changes, so the b is neglected. Similarly, in this column, if we move from second square to the third square, then we can see that the variable a changes, but the b variable remains the same. So a is also neglected. So in this way, if we move from the first square to the square corresponding to the AB states 1, 0, which is the last square in this column, we can see that both the variables a and b are going to change. So both variables are neglected. Now along the horizontal direction, if we move from the first square to the second square, then we can see that the variable d changes, so we can neglect it, but the variable c remains same if we move from first square to the second square in this row. So we will write the term c dash because the c has zero state, which can be represented by the complemented variable. Similarly, we can see in the K-map, the red marked squares are the adjacent squares which can be combined. So by combining these four squares, we have another term and we will write this term. Similarly, we can see that the green marked two squares and are adjacent squares. Similarly, we can write its term. So in this way, we will write the simplified function as f ABCD is equal to C dash is equal to A dash D dash plus A B dash D dash. Now this is our simplified function. So this function represents that we will need two AND gates to implement it and to draw its logic diagram. So we are using two AND gates, and the first AND gate has inputs A dash, D dash. So we will draw two lines, one from A dash vertical line and the other from the vertical line D dash. So these two inputs are given to the first AND gate. Similarly, the three inputs are given and these are connected with the other gate. One line is drawn from A and the other from B dash. The third one is drawn from the D dash. So we will get the ANDed form term. Now the two outputs of the AND gates are connected with an OR gate. So the OR gate will give us the plus sign between these terms. So we will implement this function in this way.